Assalamualaikum and hello everyone. Welcome to a new video for chapter 6, which is 6.2 equilibrium constant. In this video, we're going to learn define homogeneous and heterogeneous equilibria, deduce and write expression for equilibrium constant in terms of concentration and partial pressure for homogeneous and heterogeneous system. So let's, without further ado, let's define what is homogeneous and heterogeneous equilibrium. Okay, so for homogeneous equilibrium is the reaction where the reactants and product are in the same phase. Okay, but then remember, starting from chapter 6 ni, kita ada belajar yang equilibrium kan. For the reaction, kita akan guna the reversible arrow. Okay, so back to the homogeneous. Homogeneous tu, it means that it is the same. So dekat sini lah, reactant and products are in the same phase. In the specific equation, the phase is actually all of it, all of the species is in gaseous phase. Okay, next is heterogeneous equilibrium. Okay, heterogeneous equilibrium is actually where the reactant or product are in different phase. So, as we can see, reactant kita gas, tapi for our product, we have our gas and solid as well. So, itu sahaja. That's it for the definition. Homogeneous, same. Kalau heterogeneous ni, it means that we have different phase lah. Okay. So next what we're going to do is actually write expression for equilibrium constant. This is actually a continuation of our law of mass action. So dalam law of mass action ni we know lah K tu is our equilibrium constant kena product over reactant. Case ni concentration kan. Tapi sekarang ni what we're going to learn is actually K tu there are two types. One is Kc. C ni as a small c ni is meant for concentration. Kp, yang subscript P ni meant for the partial pressure. Okay. Tapi for the case of concentration, only gas and aqueous phases are taken into account in writing Kc. So contohnya kita ada general equation ni kan. So all of this is actually in gaseous phase. So it means that for for writing the Kc, all of these species and the stoichiometry will be written down as well. Okay, sebab concentration, so we must use our square bracket. And then, in the square bracket tu is our species lah. Tapi, kalau yang our to the power of, ataupun our subscript tu must be the stoichiometry in front of it. No worries, nanti kita akan use, we're gonna use this, apply this in a given equation. So, that is for Kc. Remember, it's only for gas and aqueous. And then, for the pressure. So, for the partial pressure, only gas phases are taken into account in writing Kp. So, kalau pressure kan, kalau ada solid ke, liquid ke, aqueous ke, kita takkan terima lah. Kalau concentration, gas and aqueous. Kalau pressure, hanya gas phase sahaja. So, in this case, all of this will be written down in our Kp. Tapi, cara tulis dia lain pula. Okay, so macam mana kita nak write down dia? So, dia akan jadi macam ni. Okay, so Kp stands for pressure. Masih lagi product over reactant, but since it is a pressure, so tak perlulah guna square bracket. Square bracket ni again means that it is for concentration. So kalau Kp ni kita guna bracket yang biasa, so kita akan guna P, capital P, and then kita akan buat again product over reactant. Product kita kan sebenarnya is actually C dengan D kan. Okay, so kita buatlah. Sekarang ni P, small c to the power of C. Lepas tu pressure D to the power of D divide by pressure of A to the power of A. Okay. So dekat sini dia lain sikit. So whereas kalau yang huruf yang biasa kita tulis CD yang besar ni kan, that is actually for our P lah. Lepas tu kalau yang C ni, our species tu, it will be in subscript. Kita tulis yang kecil dia. Okay, so that is actually for Kp. So remember that for concentration, only gas and aqueous. Kalau pressure, hanya gas sahaja yang kita akan take into account. Okay, so how about dengan solid dengan liquid? Pure solid and liquid always has the same concentration at a given temperature sebab dia ada same number of moles per liter. So that's why kalau solid dengan liquid ni same concentration, sebenarnya K dia is actually equal to 1. So that's why lah we don't have to write it down for the Kc ni, we don't have to write it down for the case of solid dengan liquid. Tapi kalau gas, kalau pressure ni memang kita akan specifically gas sahaja. Okay, so let's apply this knowledge for the given equation. So let's look for example A. So write equilibrium constant Kc and Kp for the reaction. Tapi kat sini Miss saja nak tulis. Remember that for the Kc is only for our gas and aqueous. Tapi kalau Kp is only applicable for gas sahaja. So kita tengok untuk example A ni. So it's only for gas dengan gas. So it is applicable. Kc kena includekan semua. Kp pun kena includekan semua. So let's write it down. So kalau nak Kc is actually product over reactant. So concentration must be square bracket. So NO2 to the power of 2 divided by N2O4. So that is for concentration. Kalau pressure pula, Kp is equal to pressure of NO2 to the power of 2 divided by pressure of N2O4. Tak perlu to the power of lah. And then it's actually for Kp is it's not a square bracket lah. Dia kiranya bracket yang biasa. So example A ni is actually example of our homogeneous equilibria. So let's look for example B pula. Okay, so all of the phases is actually in gas phase. Okay, so sama juga Kc we have to write down all of the species. The same goes for Kp. So yang ini Miss boleh laju sikit. So that is for Kc. Kalau Kp, so that is for example A dengan B. Okay, so example C, D and E, I believe you could try yourself. So next is example F. So example F ni, so let's look here. NH4Cl in equilibrium to NH3 and HCl. Okay, remember for the Kc is actually gas dengan aqueous sahaja. So dalam kes ni, gas kita NH dengan HCl. Solid ni, tak perlu tulis lah. So let's write down for the Kc. Okay, so we have written down this one. So solid ni, we don't it's not included in our Kc. So tak perlu tulis lah. Kalau nak tulis over 1 pun boleh juga. If you want to leave it here pun boleh juga. So that is for our Kc. So this is actually example of our heterogeneous equilibrium. So next kita tengok untuk Kp pula. So Kp is only for gas. So sama jugalah. Kp kita is actually for our ammonia and hydrogen chloride. So that is for example F. Next is example G. Okay, so example G ni solid je tak ada. We have our liquid, gas dengan aqueous. So for Kc, remember we want our gas dengan aqueous. So gas dengan aqueous ni. So for our Kc, dia akan jadi produk ni memang aqueous included, tapi our reactant we have two kan. Here is our liquid, here is actually our SO3 gas. So we don't have to include it. So kita tulis sahajalah SO3. Again, sebenarnya yang H2O liquid ni kan sebenarnya 1 kan. So you don't have to write it down lah. So that is for Kc. Okay, kalau Kp pula macam mana? Kp is actually for the gas phase only. So gas phase is SO3. So macam mana kita nak write down? So Kp, so maknanya this is actually our reactant. So kita kena tulis dekat sini lah reactant kita kan. Kalau if we write it down here SO3, so it means that SO3 is our product, but then this is a reactant. So kita kena tulis kat bawah ni lah. So adalah pressure SO3. So macam mana nak buat yang atas ni? Miss takkan nak biarkan kosong. So here we just gonna write down 1 over pressure of SO3. Sebab tadi dalam kes ni, when our solid is actually bila the reactant, senang lah kan. Kita tak perlu tulis. Nak tulis sebenarnya, nak tulis boleh. Tak nak tulis pun tak apa. But for this case, takkan kamu nak biarkan macam ni. Takkanlah kita nak biarkan macam ni saja. So we have to write down 1 over pressure SO3. Okay, so again, remember that for K it means that it is equilibrium constant. So when we're calculating the concentration of pressure, maknanya in this case it's actually in equilibrium. So on your notes, it will be on page 3. So, dia bagi dekat sini, the following equilibrium process has been studied at 230 degrees Celsius in an experiment. Dia bagi tahu ni, concentration of species at equilibrium. Remember, kalau K ni memang make sure it is in equilibrium. Dia bagi concentration FNO, O2 and NO2. So, they ask you to calculate Kc. Okay, before that, so before we're going to calculate the Kc, we have to write down what is the Kc for a given equation. So remember, Kc, it must be gas ataupun aqueous. So dalam case ni, all of this is actually gas. So for the Kc, all of the species is included. So this is our Kc. So remember, for the concentration, it must be square bracket. Okay. And then all the value is given. So maknanya NO2 ni, NO is this one, and O2 is this one. So we only have to substitute and calculate. So this is the value. Okay, so for equilibrium constant, it's actually sebenarnya dia ada value dia sendiri, but then for our syllabus ni, for Kc and Kp, it has no unit. Kc dengan Kp, just gonna write down, Kc and Kp has no unit. So sebab tu lah all the answers given semua ni kamu nampak tidak ada unit. Because for equilibrium constant, Kc atau Kp, it is dimensionless. Okay, so now let's look for question number 2. So number 2, the following equilibrium process at 700 degrees Celsius. There are 2.5 liter mole. There are 2.5 mole of H2, 1.35 mole exponent negative 5 mole of S2, and 8.7 mole of H2S present in a 12 liter flask. Calculate the equilibrium constant for the reaction. So again, for the Kc, remember, we have to write down for the equation first. Okay, so we have written down the Kc. So right now they ask you to calculate. But then remember, C ni stands for concentration. So kalau concentration, unit dia adalah concentration. Concentration ataupun molarity is the same thing lah. Concentration ataupun ni lah. Molarity is the same thing, where it is actually number of mole divided by volume, which must be in liter. Okay, so sekarang ni, previously we only substitute straight away kan, masukkan sahaja. Tapi sebab memang dia is in molar lah, concentration. But in this case, all the information given in terms of mole. So if you substitute it straight away, kira salah. So how to calculate it? It actually, you have to change all of this into molarity. So macam mana nak tukarkan dia pada molarity? Dia bukan yang jadi bahagi ke darab ke, bahagi 100 ke darab 100 ke, is not kan. Sebab remember, molarity is number of mole divided by volume. So dia dah bagi volume tak dalam case ni? Our volume here is 12.0 liter. So sekarang ni, from the number of mole, we have to calculate the concentration. So what I'm going to write down here is actually, Miss nak carilah one by one the concentration of H2, S2 dengan H2S. All of this value divide by 12. Okay, so the concentration has been determined. So next what I'm going to do is actually I'm going to substitute straight away. But remember, tengoklah mana ada square, make sure you square it, the value, square the value. So I'm just going to substitute here. Okay, so that's it for question number 2. So, example on page 3 and 4 ni is quite straightforward sebenarnya. You have to write down the Kc ataupun Kp. Make sure Kc, kat sini I'm just going to write down Kc must be gas or aqueous, and that Kp is actually gas only. And then, for example, if you do not get the answer, it's either sama ada salah tulis your equilibrium constant or actually sometimes salah calculator. Bukan salah calculator. Kamu careless mistake over here lah yang square ni. Make sure square dekat tempat yang betul. So then you will get the answer. Okay, question 3 and 4, I believe you could try it yourself. So sekarang ni let's look for question 5. Okay, dalam kes ni dia bagi at a certain temperature Kc is given. And if the equilibrium concentration of N2 and NH3 are 0.015 molar and 2 molar respectively, what is the equilibrium concentration of H2? Okay, so previously, the concentration is given to you. Any concentration is given, or you have to find the concentration, which is quite straightforward pun, and then you're going to find your Kc. In this case, Kc dah bagi, you're going to find out the concentration of specific species. Okay, so before that, what we're going to write down lah, what is our Kc for this equation? Okay, so this is our Kc kan? Okay, next is actually, Kc is given to you ni concentration of N2 and this is concentration of NH3. So, if you mention here kan, if the equilibrium concentration of N2 and NH3 are this value respectively, so maknanya N2 yang this one, NH3 is this one. Okay, so tak nak confuse, kita tulis je lah kat tepi kan. Just kerana apa ni? I extract all the information from the question. So let's substitute all the value in the formula. Okay, so this will be the answer. Remember, kita nak memang X lah, janganlah jadi X cube. We want X ni is actually the concentration of H2 kan? Okay, so buatlah step by step. Hence, we will get the answer to be 0.25 molar. Okay, so remember that Kc semua ni is actually equilibrium constant. So, it means that kalau concentration ke, if we have pressure ke, Kp kita is actually all in equilibrium. So, sebab tu lah kita ada nampak ni, equilibrium. So, example 6, I believe you could try yourself. All the examples on page 4 pun, I believe you could try it yourself.